Meanwhile, Eric discovered the right spring and damper combination for the front end and turns his attention to understanding whether the complex steering linkage will be strong enough to handle extreme riding conditions. He creates a simple plot to give him the calculated reaction forces on the tie rod end through the entire testing cycle. Eric will use the maximum force to run a stress test on the assembly. Eric wants to make sure he's working from the latest and greatest CAD model. He sees all green check marks, which lets him know everything is current and he can move on with the stress analysis. He adds boundary conditions to simulate how the steering linkage assembles to the frame and uses virtual pins to simulate the joint locations. After adding the maximum load to the tie rod end, he runs the analysis and views the results. He can quickly see that the system passes the factor of safety test and then checks the maximum displacement just in case. It appears the torsion rod is twisting so much it could affect the rider's ability to control steering. He changes the material of the torsion rod to something a little stiffer and reruns the analysis. With one simple change, he's reduced the total displacement by nearly 25% and now feels comfortable with the steering system's performance. To complete the task, he saves to the cloud so the design can be shared with the manufacturer.